because gathering the data is fantastic to say that we've got the data, but using that data to once again make stronger predictions and more confident decisions is paramount. So we're going to spend a good bit of time of how Sysmac Studio allows users to be able to make better decisions based off of the data that they aggregated without compromising performance and transported without introducing additional vulnerabilities onto the factory floor. All right, so if that's kind of where we're going, how IIoT and Industry 4.0 work together, let's get into what is Sysmac. So when we talk about Sysmac, we're going to talk about really how Sysmac is not only that automation architecture or that platform, but how it unifies the IT and the OT space in order to help both teams meet not only the metrics of which they're measured by, but also help them achieve more and prepare for new technology to be seamlessly integrated into their factory. So what we're showing here is our controller. So at least here in Omron, we call these machine automation controllers because they have motion and safety as well as control. And we use a lot of EtherCAD and safety over EtherCAD in order to maintain not just control, but that deterministic motion. Deterministic motion is so important when it comes to machine performance, not only in terms of easy to set up, but also having those refresh times being very quick to ensure packet delivery is, well, really guaranteed. We're also going to talk a little bit about IO Link and how IO Link has the ability to, once again, not only be set up very quickly, but give that granularity of data needed in order to find root causes for inefficiencies in the system. So this is just a snapshot of the Sysmac breadth of a whole lot of different products that, once again, are designed to work together over the globally open industrial protocols, EtherCAT, and failsafe over EtherCAT. Now, if we look a little higher up and look at where a lot of this data can go, we're seeing, of course, the ability for Sysmac, once again, that automation platform, being able to move data to a cloud, also being able to move data in those larger packet sizes using Ethernet IP to, once again, SCADA systems, industrial PCs, and then also into the integrated development environment here in Omron, we call Sysmac Studio. So when we look at all of this together, what we're seeing is the Sysmac portfolio is designed to be holistically controlled, but then also have a single connection, a single controller, and a single software environment in order to unify so much that we're seeing on the plant floor, and especially as the factory is becoming more and more digital thanks to IIoT and Industry 4.0. And a big takeaway here is at the nucleus of this architecture, you're seeing that controller. And once again, this controller is designed to minimize vulnerabilities moving from the top that kind of IT level into that OT level, but also using globally open industrial protocols to unite the factory while also using these globally open industrial protocols as they were designed, which is, of course, why you'll see EtherCAT down here for machine control and Ethernet IP up there for the information and the factory automation. All right, so if that is a relatively quick introduction to Sysmac, let's dive into how the platform Sysmac integrates into IIoT. And let's go back to these three buckets, looking at data aggregation at that device level before we jump into securely sending data and visualizing that data. So let's first look at that device level and how Sysmac attacks that. All right, so the first big design principle when we were starting to put Sysmac together is the networked sensors. So what you're seeing is, once again, a whole lot of sensors and a whole lot of capabilities within Sysmac, once again, on the protocols that maximize that benefit. So you're seeing a lot of sensors on IO Link, you're seeing a lot of motion on EtherCAT, and then you're seeing a lot of safety and large data packets on Ethernet IP. And the purpose of doing this is making not only the design very easy and transparent, but also allowing it to be scaled up very, very quickly. And we've got a number of new products even coming down the pipeline that are going to continue to complement this. So the first big pillar is choosing more data and using the breadth of sensors, not just available here at Omron, but also through third parties as well to get all that data to begin with. So if that's the device level, now let's look to that controller level. And one of the newest controllers that we have here at Omron is the NX5 controller. This quad-core CPU, while it has the ability to move a lot of data and also maintain control up to 16 axes of motion, what it also has the ability to do is create subnets. Now, this is very important, not just when you expand the capability of automation across the factory floor, but also mitigating risks by segmenting your network. So let's jump into what this looks like inside of a panel. So everything on the left-hand side is plugged into what we call our X bus. This X bus is a high-speed bus designed to move a whole lot of data and a whole lot of control. And all of the network cards that we put on the left-hand side are right now Ethernet and SIP safety. So you can communicate through both protocols in the same gigabyte port. So this is extremely important when communicating with robotics, but also being able to have that flexibility. And you can go up to 4 network cards on the left-hand side of this NX5. On the right-hand side, you're going to see all the same NX-IO that we have available in what we would call our machine level or machine scale controller, which would be something closer to the NX102, all the way up to something that has 256 axes of motion on our NX7. But all of the I/O on the right-hand side has the ability to work with both of those. And to add to that, we're also showing our safety processor, our safety CPU, which can go on that right-hand side of that NX5, allowing for both safety, motion, and of course data to be in a central unit, thus allowing so much unification that is needed as, once again, IIoT continues to permeate into the industry. All right, so continuing down the path of being able to move that data, we're also leveraging a lot of OPC UA, SQL, and MQTT across SysMac controllers. So let's kind of dive into what that looks like. So here on the left-hand side, we've got kind of a showing each NX502 controller, and all of these NX502 controllers have OPC UA and SQL built in as standard. And that's so important because typically there is a computer needed on the shop floor or factory floor to broker that data. But building that into the controller, that means a lot of teams can start transporting data to a third party out of the box. We do have function blocks for MQTT as well. And while, of course, we're just showing that kind of larger line scale controller, we also have that machine level, and the NX102 can do the exact same thing. So once again, you're seeing this consistency that the SysMac portfolio uses a breadth of different protocols in order to, once again, unify a lot of automation and help users identify the most efficient path to not just control their automation, but also control their data. And the good news is, Raj, you've got a demonstration coming up that dives into this in further detail. Is that right?
That is absolutely correct.
Okay, perfect. All right, and the last one is security. Here at Omron, we're seeing more and more users consider their data confidential or proprietary. So adding features into SysMac Studio. Once again, SysMac Studio is that software that allows users to design and commission a lot of their programming. But we've got features now coming out and have already come out that really fight that man-in-the-middle attack and also limit the amount of users who can access the controllers. Once again, we're continuing to put safety at the heart of this design. All right, so We've talked about that device level. We've talked a little bit about sending data securely. Let's dive into visualizing the data. So when we introduced Sysmax Studio, we talked about designing programs and then validating the performance. So within Sysmax Studio, we have a number of simulations that are available. Of course, we've got the standard logic and HMI, but also motion and now 3D simulation, where 3D simulation can allow for SolidWorks models to go ahead and be dropped in there so you can mimic that automation before everything is built on the factory floor. What this does is not only allows multiple teams to see how the automation will end up performing to make sure that all team members can provide their value and provide their insight into building this machine. But it also takes a lot of risk off the table when designing new equipment or upgrading old equipment to make sure that everything is performing as intended before it's deployed onto the factory floor. And the good news is all this simulation is built into Sysmax Studio, and all the simulation does not require any hardware, which means the development of the program can be in parallel to the development of the actual hardware itself. So once again, the goal of the simulation is to start creating that data and start setting that mindset and that expectation of how automation should perform. Because once again, once you have a target, now you can start to try to exceed that target and make sure that you hit that target if anything starts underperforming. And this is just an kind of a video automation of what that looks like. On the left-hand side, we've got some robotics being simulated within that Sysmax Studio software. Of course, we've got the ladder logic there on the left-hand side showing how this simulation is rolling. And now on the right-hand side, we've actually built that example, and now we've got them running side by side. And the power of this during any commissioning or first pass yield is verifying, yes, everything is performing the way we intended. Once again, taking that risk off the table. And once you start taking that risk off the table, then you can start accelerating projects. All right, so if that's more of the commissioning side, what about once the automation is already deployed? So once again, we're talking about visualizing data and being able to make better decisions because of that data. So once everything is deployed onto the shop floor, you need that feedback. You need that data to close that loop. And the NX5 has the ability now to play back variable data ladder logic and video, up to 15 minutes of it whenever an event is recorded. And that event recording can be built into the program itself. So if an event occurs or if something needs to be recorded when nobody is around, the controller itself can record that data. And we're showing this convergence of this playback from ladder logic, variable data, and video, because once again, the power of Sysmax is that controller is sitting at the nucleus of the architecture. So by having all that unification capability, by having that holistic data, you have the ability to play it all back. You have the ability to have your ladder logic, your video, and your data time synchronized, which is very important when you're trying to find that root cause of a failure or a deviation from what should have happened as shown in a simulation. So let's dive into the automation playback. So whenever you introduce a feature like this, the first goal is allowing the overall design principles of the platform to be maintained. And so much of Sysmax and the Sysmax Studio is having out-of-the-box features as standard and also being able to easily integrate it into a current environment. So it should be no surprise that there is no additional cost for automation playback within Sysmax Studio. For those who are already using Sysmax Studio, if you automatically update your software past version 1.54, you've got automation playback. All you need is an NX5 in order to start reaping the benefits of that. Also, because we're using so many globally open industrial protocols, an event can be triggered anywhere within that ladder logic. So no one has to be present to hit record on this playback. That can be done within the program, and any of the sensors that are capable to be used in Sysmax Studio can be that trigger. Of course, all NX5s out of the gate have this capability, regardless if it's the NX502 1300, 1400, or 1500. So regardless of the axes of motion, all of the NX5s have that capability. And then lastly, there's a host of cameras that our global team and our team here in the Americas have validated the performance on. And so if that's integration into Sysmac, when you start to have a whole lot of data, being able to very quickly find that root cause is very, very important. So there have been a number of search features and functions that have now been built into Sysmac Studio in order to find that root cause. The first is having the ability to search based off of a certain variable. So if a Boolean goes from false to true, you want to be able to say what points in time did that occur. The next is being able to visualize all of the data. We go back to that a picture is, I guess, worth a 1,000 words, and that's what's happening over here. So you have the ability to visualize all the variables, just a couple, and the goal here is once again to try to eliminate that noise to find that root cause. The last one is the NX5 has the capability of recording up to 15 minutes of data, ladder logic, video, and program structure. And that event trigger can be anywhere in that 15 minutes. So if, let's say, in the ladder logic, something is completed, we want to save that data, it can save up to 14 minutes and 59 seconds of all that data prior to that recording. So in that 15-minute window, you can set that event trigger anywhere in there. So if you wanted 14 minutes and 59 seconds of after event triggered recording, you've got that option as well. And lastly, and this is really the party piece to the NX502, is cycle refresh rates are not changed whenever the unit is recording or not recording. And a real driver of this is the NX5 is always watching that data, and it's just waiting for the trigger to keep the data. So it's always recording. It's just waiting for an event trigger to say, okay, go ahead and keep that last 15 minutes. And the real benefit of this automation playback, of course, is during commissioning and doing a first pass yield and comparing what should have happened, such that simulation, compared to what actually did happen through the automation playback and overlaying those two. The second is anything that occurred unexpectedly. So if the line goes down at 2 o'clock in the morning, everyone shows up at 7 in the morning saying, hey, from 2 to 2:15, the line was down. Teams are able to go back and look at this data to figure out what that root cause is. And the very last one comes in terms of starting to build large amounts of data for future AI, where we're seeing users record every part that goes through the system in order to gather all this data, in order to either help train generative AI or start to be that basis for traditional AI. And this is just kind of a image of Sysmac Studio. So once again, this is a desktop app that can be downloaded, installed, and can be accessed for the first 30 days without a license. So everyone here can start downloading it and trying this out today. But what we're showing here is the playback itself. So of course, the program is opened in Sysmac Studio, just as you would for designing and commissioning. But of course, because we've got that automation playback, that upgrade, or I guess that update in the software, here we are just showing the replaying of ladder logic, our video with sound, and of course, our variable data as well. So having the ability to replay this once again is extremely powerful for finding that root cause or building up a backlog of great data. All right, Raj, I think we're right on time. So I've got still control of the screen. Would you like me to stop sharing so you can start diving into the demonstration?
I will, let's stay on this screen for a little bit, Thomas, and then I will share my screen.
That sounds perfect.
Awesome. Thank you, Thomas. That was a very well put high-level introduction into our Sysmac Studio platform, and specifically the NX502. Now that we have the overview, let's get down to specifics, right? Let's get to the factory floor and get our hands dirty, so to speak. Now, you might have noticed that the theme for today is data. and how we converge IT and OT into one controller. So what we want to show you is a typical factory environment that where we can actually utilize this NX502. So before we connect to high-level platforms such as SQL databases or SCADA platforms, we first have to decide what hardware we are going to use, right? So in order for us to get the maximum amount of data from hardware, we have to use hardware that is capable of providing that data. So if we look at the production floor, you'll notice that we do have all of our motion and I/O standardized on EtherCAT. EtherCAT network provides a lot of feedback from the different devices that you might use on the factory floor, as well as status data. Then the most important thing is when you go down to the sensor level, how much data can we actually gather from the sensors, from proximity sensors, from photoelectric sensors, and CMOS sensors. So in order to do that, we will use IO-Link, which is an open platform. And then we will go into how much data can we gather from that kind of a network. So with that being said, I will take control of the screen so I can show you what a typical network might look like. Thomas, can you see my screen?
I can. It looks good on this end.
Awesome. Sounds good. So the first thing we'll discuss is what I have on my screen, right? On the left-hand side, I have a soft NA screen. This is the same HMI software that you would see on a Omron NA HMI. You can run it on a Windows PC as well. So this is what I'm doing here is I'm visualizing the data using the Omron soft NA platform. And on top of that, I do have Aviva Edge activated on this computer. Aviva Edge is a SCADA platform that we have partnered with Aviva Edge for a long time. And that is visualizing some data here as well. So let's look at the EtherCAT network first. If you use EtherCAT network, you can get a lot of data from your devices. So for example, in this example, I have a server drive. And if I start the machine cycle, you can see that I can get real-time information from the server drive. I don't have all the data that I can actually read from the server drive here, but you can get the idea that you can read a lot of data through the EtherCAT network on all of your EtherCAT nodes. Then if I go back, if I look at the IO-Link network, this is very interesting because you might think that in order for us to get data from a sensor, number one, the sensor has to do a lot compared to a standard, on-off functionality. So if you look at like a CMOS sensor, like an E3AS HL CMOS sensor that we can provide you guys, yes, you can get light intensity level and the actual detection distance from the sensor as well. But you can get a lot of status data, such as if you are not receiving enough light, which might indicate that it's time to maybe clean the sensor or replace the sensor. So you can get a lot of data like that using IO-Link. This is valid for even a proximity sensor. For example, I have this proximity sensor set so that the object that it detects is not totally on top of the sensor. It is like maybe quarter way, so that the sensor is actually detecting the object, but it's not actually getting a stable signal. So it's giving me an error stating that I'm detecting something, but it's not stable. So you can look at all these data to actually read into this and say, okay, well, it is time to maybe adjust the object that's reading from the prox sensor, or for your predictive maintenance schedule as well. So now that we have all that data coming into the controller, Now it becomes, okay, well, what business units need what data using what protocol? This is a very important point where you have to communicate with business units to talk and to figure out what communication protocol to use based on the need. So, for example, in a factory floor, you might have a supervisory control unit which needs to monitor the factory floor as well as save some data into an SQL database. So in this example, I'm using Aviva Edge to monitor the factory floor, as well as I am sending data into an Microsoft SQL server and to create a dashboard to using Power BI. So in this example, right now I am connecting to the SQL database and it's telling me that the connection was successful. And if I start my machine cycle and if I go to Power BI, now you can actually see that the dashboard is populated in real time. And it's so easy to set up the SQL database. And all you would have to do is underneath the connection settings, you will need the IP address of the database and the login information, and you can successfully connect to it. And then, of course, we do have the pre-built function blocks where you can connect to a database, create your mapping for the table variables, and then insert data. It is that simple. So that's the main point that I want to highlight is when we designed the NX502 or the SysMac controller, we wanted to use open protocols so that we can converge IT and OT. And also we wanted to make it easy for the automation engineer to actually use it so that you can use the ladder programming language that you know to actually connect to these high-level IT databases. And also, one of the highlights that I want to talk about is because the NX502 can separate Ethernet IP networks, now you can add several 1 gigabit speed Ethernet IP units on the X bus on the left-hand side, and then you can connect to different networks as well. So in this example, you might come across another business unit and they are using MySQL and they want to build a dashboard using Grafana. So in this case, I will connect to the MySQL database and I will build a Grafana dashboard. This is a dashboard that I have pre-built, but you can actually see that it's being populated in real time as well. So this is possible because of the capabilities of the NX502 and its powerful processor, as well as the additional capabilities of network segmentation. And of course, there may be other business units that might actually require data using MQTT protocol. MQTT is a very lightweight protocol that's being utilized more and more in the automation industry. So in this case, MQTT broker will need to be connected to the NX502. In this case, I'm connecting to the MQTT broker, and it's giving me feedback saying that it is connected. And I am publishing all these data into different topics because in the MQTT world, variables are called topics. And I am subscribing to the same topics using the NX502 controller as well. So because this is connected to Aviva Edge, I can use Aviva Edge to monitor data coming through the MQTT protocol as well. Now, you might actually see a pattern here, right? You might be seeing that, yes, we do have connectivity for all these different protocols, and we can either do it on the machine level using our own NX502 controller as well as the NAHMI, or we can do it on the supervisory control level using a SCADA platform as well. And the main thing I want to highlight after MQTT is we do support OPC UA as well. OPC UA is an industry-wide protocol that's mainly been used with SCADA platforms. And it is, again, very easy to set up. All you would have to do in Sysmax Studio side of things is to set up the OPC UA server settings and make your global variables as a publish variable. And the OPC client, in this case, is the Aviva Edge platform again, will have access to those variables and you can monitor those variables. So the main highlight for today, as we discussed, is the convergence of IT and OT using the NX502 controller, which actually gives you the flexibility to decide what software you want to use with what protocol. And we do support a lot of communication protocols. The main ones are highlighted here. And then you can design how you want to plan out your network architecture. With that, I think we discussed all of the topics we wanted to talk about today. Do we have
Raj,
any? Yes, sir.
Oh, go ahead. Saying that there's two great points on this image that you still have up here, and the first is that granularity of data. Where yesterday, being able to tell if a motor is on or off was good enough to start troubleshooting, but a lot of that low-hanging fruit in terms of OEE opportunities and growth have already been picked. So having an on-off as your only data might not be enough anymore. So now it's the amp pull. It's the what was that torque on that unit at that exact time. Because once again, if you're looking to maximize uptime, you can set those thresholds. You can start trending that data. So I love that you went into that and really showed how that resolution of data can be so powerful, especially when you overlay that with automation playback or with a simulation. You can really dial in that performance. And the second was there's a lot of different downstream consumers of data. Certain audiences and constituencies are looking for very certain types of data. But the fact that this controller is that central hub distributing or publishing that data means everyone's looking at that same process. Everyone's looking at that same action on the plant floor, but everyone can see it from different perspectives and of course bring their talents and value to solving those bigger problems while avoiding a lot of those data silos that we end up seeing. So those are two fantastic points, Raj. Thank you so much for demonstrating that. And this was all live in Sysmax Studio, right?
Exactly. Yes, I do have everything connected live. And the main point I want to highlight as well, Thomas, is when you collect data from the controller, now when we have to send it to business units, security becomes extremely critical. All the protocols that we have highlighted today, SQL, MQTT, OPC UA, are inherently secure. MQTT uses TLS encryption. SQL uses TLS encryption. OPC UA is inherently secure with security certificates. So we do support cybersecurity, and every time we want to bring in something new in terms of a communications protocol, we do keep in mind that it has to be inherently secure because of the convergence of IT and OT.
Yeah, excellent. Thank you, Raj. And Matt, I think we're ready for the next stage, which could be a little Q&A.
Yeah, we had a few questions got emailed to us between yesterday and today, and some of them a little more specific, some of them a little less specific. So first one that came up is a little curious one is there a relationship between Industry 4.0 and AI? Industry 4.0 being around for a little bit, would it be like 5.0, 4.1? You know, let's see. Does that still act as this generation? You know.
All right, Raj, do you mind if I jump on this one, and then you can correct me for anything I may kind of embellish a little.
Absolutely, go for it, Thomas.
Cool. So when we talk about artificial intelligence and AI hitting the shop floor, at least here at Omron and here in Sysmac, we really like breaking it up into three buckets. The first is the creation of the data. So this is once again using protocols such as IO-Link to get really reliable, robust data. So that first bucket is getting the data and transporting the data without compromising machine performance. The second bucket is the algorithm itself, whether it's traditional AI or either through supervised, unsupervised, or reinforced generative AI learning. That's kind of that second bucket. And the third is being able to deploy any remediation or any predictions that that algorithm has been able to glean from the data. So as we look at how Sysmac, Industry 4.0 all interact with so much hype and excitement around AI, we're very much focusing on that first bucket, that ability to get that data, that robust, reliable, holistic data, and getting it to the point that that algorithm can actually start to use it. And then also on the other side is making sure that we have an architecture that can take that insight, either gleams from individuals, from data scientists, or autonomously, and deploy a mediation downstream and do it in real time. So when we look at using the right globally open industrial protocol for the right purpose, that's where you're finding that. So that's kind of where those two kind of fit into that kind of algorithm itself. Raj, anything you want to add to that?
I think you explained it perfectly, Thomas. I think we have seen some of our customers, they are diving into AI, and it's the main requests have been the speed of data as well as the protocol that we want to support. And we have seen a lot of customers ask for MQTT data, and then they want it in a faster speed as well. So the NX502 supports 1 gigabit speeds on all of the network ports, which can facilitate that data collection as well.
Cool. Nice. I think that's good. A succinct enough answer. I want to say thanks to Eric Cross for being in attendance. He wanted to say both thank you to Omron and Mechatronic Solutions for a very informative webinar. I do have a few more questions. I'm not sure if they're gone. They're probably gone. But I did want to ask, this one's a little bit more for me, I think, is do all NX controllers have Ethernet IP?
All right, Raj, do you want to take that one?
Yes, yeah. All of the NX controllers have Ethernet IP capabilities, as well as the NJ controllers. They do have Ethernet IP capabilities as well.
Cool. Okay. Sorry, run through my notes here. Does automation playback, is that just kind of like baked into it, or does that require an additional license?
No, it is included in the standard Sysmac Studio license. It does not require any additional licenses.
That's cool. Nice. I genuinely think that's cool. I'm not like, yes,
I appreciate it.
Why are you so great? You know,
that's good to hear, Matt. That section wasn't scripted. That's
good. Do I need this one? This one, I'm hoping we get really into the nuts and bolts for it here. Do I need a specific controller to ensure that I can use OPC UA?
Raj, do you want to take that one? Or I don't mind, since you took the last two, I don't mind trying this one out.
Sure, go for it, Thomas.
Okay. So in short, NJ and NX controllers that have the suffix 20 indicates that there is OPC UA built in. So let's look at the NX 102.12.20. That unit would have OPC UA, while the NX 102.12.100 would not. However, the NX 502 kind of breaks that mold where there is no suffix for 20, yet all NX 502s have OPC UA as standard. And a lot of this has to do with, as we look forward, being able to move data to Grafana, Aviva, Power BI. This is becoming more table stakes and more standard, and a lot more automation. So Therefore, it's becoming a standard feature. So as we look towards the future of SysMac, what users can expect is more and more features becoming standard as the connectivity within the plant floor increases. So once again, the goal is to remove that complexity and allow teams to have the ability to connect to a breadth of third-party programs. Raj, is that fair to say?
Absolutely, that is, you explained it beautifully.
But it does help, Raj, that I run all my answers by you first.
Cool. Okay, last one. For the 3D simulation that we were shown earlier, is that something that we can import with SolidWorks?
Raj, you want to give that one a go, or you want me to?
Yeah, I can take that. So
okay.
You can import 3D models into the project. To import 3D models, you do need a separate license. But let's say if you want to build a 3D model inside SysMac Studio using basic building blocks, you can do that without an additional license.
Okay, cool. I think that's it. Those are all the questions that came in beforehand, and no additional ones came in during the chat. I did provide a window for people who pre-signed up to be able to send their questions in advance. So yeah, I guess that's pretty much it. Any other notes, closing comments you would like to make?
No, I would say just thank you, Matt, for giving us the opportunity to dive into this. Thanks for letting us start at that high level and drill down. And I mean, the 2024 is still very, very young. So if anyone on the call has any questions as they're starting to ramp up their factory for the new year or starting to look at capital projects, if there's any clarification we could provide, absolutely let us know. We're here to support and answer any questions from not just the Omron standpoint, but even from these globally open industrial protocol standpoints as well. Raj, anything you want to kind of close us out with?
Yes. So in terms of IIoT, Omron has a specific team dedicated to help customers with building their network architecture as well. SysMac architecture team takes on those kind of projects and help customers on building the IIoT infrastructure. And SysMac application engineering team is here to help with any SysMac Studio or SysMac product related questions as well. And lastly, Mechatronic Solutions and Matt, thank you so much for organizing this webinar. That gave us a good platform to showcase our capabilities within SysMac Studio.
Yeah, thank you so much. Well, hey, awesome. Well, thanks so much for the attendees for showing up. And of course, thanks to our gracious host for providing us a lot of great information. You can always reach out to us at info@Mechatronic Solutions, and we'll make sure to forward any additional questions you might have to Raj and Thomas, respectively. And outside of that, thank you all so much and have a great day.
Thank you so much.